Hi, we're going to be talking about estimating square roots, and then we'll do a quick little introduction to cube roots today. So, estimating square roots is what you need to do when you don't have a perfect square. If you don't have a perfect square, you can still get a rough idea of what the value of that square root is. So, for example, if we have the square root of 18, you might notice that 18 is not a perfect square, and if we need to estimate this, what we can do is recognize what perfect squares are close to 18. The closest perfect square that is less than 18 is 16, and the square root of 16 would give us 4. The square root of 18 would fall somewhere after 4. And the next perfect square after 18 is the square root of 25, which is 5. So what that tells us is that the square root of 18 is going to be 4 point something. It's not going to be as big as 5 because it is less than 25. So it looks like it's a little bit closer to 16. And what you can do is even go as far as approximating it using a fraction. So we know it's going to equal 4 and some part of a number. And what you could do then is look at the distance between 16 and 25. So if you take 25 minus 16, that gives you 9. So you have 9 spaces between 16 and 25. That would be your total spaces between those two numbers. And 18 is 2 spaces beyond 16, so that would be your numerator. This is not the value of the square root of 18, but it is an approximate, it's an estimate. So the square root of 18 is about 4 2/9. So if you type that into your calculator, you would get a value that would be very close to what you would get if you typed in the square root of 18. So you could say, if you didn't have a calculator, that the square root of 18 is equal to approximately 4 2/9, or if you wanted to write that as a decimal value, 4.2 repeating. Now it's important to note that if you have a square root of a number that is not a perfect square, you will not get an exact answer. Your calculator, when you type it in, will give you a screen full of digits. And that is because perfect squares end as an integer, and non-perfect squares, when you take the square root, do not. They are called irrational numbers. They don't end, they don't repeat, they just keep going on and on. So, good to note that you will never get a nice little answer when you type in the square root of some non-perfect square. It will always be a screen full of numbers, lots of digits after the decimal, and that is the correct result. Okay, let's look at another example. Let's estimate the square root of 6. So noticing that 6 is not a perfect square, we can't get a nice value. The answer is not 3. A lot of times when students begin looking at square roots, they think, oh, I just cut this number in half. But remember, 3 times 3 does not give you 6. 3 times 3 gives you 9. So the square root of 6 does not equal 3. The square root of 6 is going to be somewhere between the perfect square root of 4 and the square root of 9, because those are the two perfect squares that are around 6. The one that's less than 6 is 4, and the one that is greater is 9. So we know the square root of 4 is 2. We know the square root of 9 is 3. So we know that the square root of 6 is going to be 2 something. We can find that fractional value that we can use to estimate the square root of 6 by looking at the distance between our two numbers that are perfect squares around 6, which are 4 and 9. So the distance between 4 and 9 is 5. That becomes the denominator of our estimate. And then you want to look at how far is 6 from the smaller value. So there were 5 spaces between 4 and 9, and 6 is 2 spaces away from 4. So that would be 2 2/5 for our estimate of the square root of 6, which works out nicely as a decimal. And it won't be nice as a decimal when you type it into your calculator. Remember, this is going to go on and on forever. You'll have a screen full of digits, but it will be approximately 2.4. All right, let's do another one. Let's look at the square root of 54. And again, we're still estimating because 54 is not a perfect square. You want to have a pretty good idea of what the perfect squares are. So in my last video, I mentioned it might be helpful to memorize them. So if you haven't done that yet, you should recognize that 54 isn't too far from 49, and 49 would be 7 squared. So 49 is a perfect square, and it is the perfect square that is closest to 54, that is less than 54. So if this one's 7 times 7, the next one would be 8 times 8, which would be 64. So now we know square root of 49 is 7, square root of 64 is 8, square root of 54 is going to be some number approximately between 7 and 8. To find that value with just estimating, it's not the exact value, you need to find the distance between 49 and 64. And we get 15. So our denominator in our estimate is 15 because that's how many spaces are between the two perfect squares that are around 54. The numerator is how far 54 is from the smaller of the perfect squares. So the distance between 49 and 54 is 5 spaces. So now what we have is 7 and 5/15, which we know simplifies down to 7 and 1/3. And hopefully you know that 1/3 is just 0.3 repeating. So our estimate for the square root of 54 could be 7.3 repeating. All right, so another type of question you might be asked looks like it might be more complex than what we've just been talking about, but it actually is a little bit easier. You are not being asked to estimate the value of the square root of 62. What the question says is the square root of 62 is between which two consecutive integers? So we probably need to talk about what consecutive means and remind you what integers are. So to remind you what integers are, remember they are numbers that don't have decimals or fractions. They're all of the positive whole numbers, all of the negative numbers that don't have decimals or fractions, and 0. So numbers like -3, +12, 0, those are all integers. No decimals, no fractions. Consecutive means one after another. So for example, 2 and 3 are consecutive numbers. They're consecutive integers. -6 and -5 are consecutive integers. So that's what we're looking for. We're looking for the consecutive integers that are around the square root of 62. So let's look at the square root of 62 and think about the perfect squares that are less than 62 and greater than 62. The one that's greater than 62 is hopefully pretty quick for you to recognize because the square root of 64 is a perfect square, so its square root is 8. And if we know that the square root of 64 is 8, the next lowest one must be 7, and 7 squared is 49. So 49 is the perfect square that is less than 62. And so what we've done is we just started a problem similar to what we were doing for examples 1 and 2, but we're actually already done. We don't have to find the decimal or the fraction that the square root of 62 could be estimated by. We just need to say that the square root of 62 is between 7 and 8. So the square root of 62 is between which two consecutive integers? 7 and 8 is your answer. All right, let's just do one more of those to make sure you've got it. So now we're looking at the square root of 125, and that is not a perfect square. We're not being asked to estimate it. We don't need to find a decimal value or a fraction value that estimates it. We're just looking for the two closest perfect squares around it so that we can say that the square root of 125 is between their square roots. So if you haven't memorized your perfect squares yet, it certainly will make these types of problems quicker. But you might know that 11 squared is 121, which is certainly very close to 125, which means that the next one must be 12. And if you don't remember, the square root, or 12 squared is 144. So the square root of 144 is what gives us 12. So the square root of 125 is between 11 and 12. It's going to be some decimal value between 11 and 12, but we don't have to say what the decimal value is. We're just saying that it is between 11 and 12 because they want the consecutive integers that it's between.